Hello everyone, welcome back to the channel. I hope you guys are doing really well. So we will see today's daily challenge on LeetCode and we will try to solve it together. Okay, so if you see today's daily challenge, it is a very difficult one, and if you try to see the editorial or other solutions, you might not get anything at all. But yeah, I will try to make it as simple as possible. I will show you something different and very interesting one. I will show a simple recursive as well as memoized solution which will actually be accepted. Okay, so and I will show you that what I have been telling in my DP playlist, that no matter what is the problem of DP, you can always solve it by recursion and memoization. Some problems of DP may be easier uh, by iterative methods directly, but yeah, most of the problems can be solved by these recursive as well as memoized method. And how interesting this problem becomes, how easy this problem becomes from a very hard one, we will try to see. Okay, we will try to understand. Okay, so let's try to understand the problem statement at the very first. Okay, so maximize the number of partitions after operations. So you are given a string s and an integer k. First, you are allowed to change at most one index in S to another lowercase English letter. So basically you are given a string and a k and integer k, so you are allowed to change only one string and you need to maximize some partitions. Okay, so what is that partitions? It is defined here. So you do the following partitioning operation until S is empty. You choose the longest prefix of S containing at most k distinct characters. Okay, and delete the prefix from S and increase the number of partitions by 1. Remaining characters, if any, in the S maintain their initial order. Okay, and you need to maximize this total number of partitions. So we will see how we will try to visualize this example and try to see what exactly it wants us to do. Okay, so let's say we have this A, triple C and A. Okay, we have this, and K is nothing but 2. So you see, what can you do? You see, number of distinct characters. What is the number of distinct characters? It is already 2, right? So if you try to select the longest prefix, it will be the whole string itself. It will be the whole string itself. So you see, you can delete the whole string at once in just a single partition, and you will have an empty string with you. So your number of partitions is 1 in this case. Now if you try to change some character, let's say I am trying to change this A to X. Okay, I will try, then what I will get? I will get X, triple C and A. Okay, so now if you try to perform the operations and try to count the number of partitions, what you will get is that the longest prefix is X and C because this has distinct characters. But no, wait, the longest prefix containing two distinct characters, it is nothing but X triple C, right? This whole prefix has just two distinct characters, and in one operation you can simply get A. Okay, you remove this whole string and get A, and in the last operation you can just have an empty string with you. Okay, and the total number of operations that took is 2. Okay, so you try to see that what can you do in such a case is that, why not try to change the second C, try to change the C this. Okay, so A X C C A, what if I try to change it in this way? Then you see, this is again, what will be the prefix which contains two distinct characters? It will be A and X. I can try to choose to remove this to get CCA, and then you see this whole string has only two distinct characters. I can try to remove this and get an empty string, and I will have again two partitions. So how can I maximize this? You can maximize this by trying out several methods. You can't say for certain that what kind of pattern will you see, what kind of pattern will you see or visualize in order to actually maximize this. It is very difficult to tell. So you can just, what you can do is try each and every possibility. So let's say you want to change this C to some other character, let's say X. You can easily see that you can choose to remove this A and C, and you will get a partition added to your answer, and you will be remaining with X, C and A. Now since K equal to 2, you see the number of distinct letter X and C is the longest partition again, and now you can add this and get an A, and in the last step you can add one more and get an empty string, right? And your answer will be 3 in this case. It can be shown that in no other way you can get an answer more than 3. Okay, So but how do we know this all things? Okay, so I hope at least the example is very clear. Okay, example should be very clear to you in order to proceed. Okay, uh, and I think understanding the examples is not a big deal at all. So let's try to approach it. Okay, so as I told you, I will try to do it by recursive method. So why does recursion first come to your mind, and why at all do we need DP for this? Okay, and how is it actually different from the usual ones? So you see, you need to find an optimal way, right? So what can you do by very brute force, right? Very brute force, what can you do is that you can choose that let's say I will select the first character and I will replace it by, let's say, A I will replace by B or C or D or E and so on till Z, and then again I try to replace this character by all of this A, B, D, E till all till Z. Okay, and so on. Okay, I will try to do it for every case. So this gives me a brute force idea at the very first. Okay, but definitely such a kind of brute force idea will not work. So what you can do, you can choose to have a pointer and apply recursion. Okay, so how do you solve recursive problems? You see, you have an pointer I pointing to this index and you want to, let's say, calculate that what if I want to change all of this? What if I want to change all of this? So basically I will write the brute force solution only at first and try to memorize it further to make it a recursive DP. Okay, and make it actually work. So what will I do is actually have an index, and that index will keep on moving. It will start from 0 and it will keep on moving till the end. Okay, and we will try to keep track that in our current partition, in our current segment or the current partition, how many distinct characters are there, how many uh, distinct characters are there. So if that distinct characters, let's say that distinct characters count is, let's say, CNT. Now if this distinct characters count exceeds k, so let's say I am at a point, I am traversing in a string. Okay, this is a string and I am at a point where I am adding a current character. This is a current character and I am adding this, and I see that, hey, now the count gets greater than k. Then I do understand that I need to do a partition. I need to do a partition at a point which is just before this current character. Just before this current character, you need to do a partition. This much you understand, right? I hope there is no difficulty. So I will have an iterator I which will start from 0 and go on till the end. Okay, and what I will try to do is that I will try to see whether I want to include my current character in my current partition or not. Okay, if you see, if on including it, this count, this distinct character count actually increases greater than k, then I want to say that I want to keep a partition before that. Okay, and there is another choice also, whether I want to change the correct characters or not. That I will do a brute force solution. What I will do is that I will have an I which will go from 1 to 26, 25, in fact 0 to 25, and it will try to change everything. It will try to change this current character to all of these characters. Okay, let's say 0 denotes A, 1 denotes B, and it will try to change, and let's see what happens. Let's try to write the recursive solution and see what happens. Now you see, you need this, how many distinct characters you do want. Okay, so I will try to keep a mask for this. Okay, that mask will nothing be an integer, and I will call it current set. So how will that mask look like, and why am I using a mask at all? First question is that. So you see, uh, because I want to store this whole thing as an integer only, and I will try to store it in some way. Let's say A, B, D and F. Let's say this is my string. I will try to mask it. How? Let's say this first position will denote A, the second position will denote B, the third position will denote C, D, E, F, all the way till Z. Okay, so I will mark a 1 whenever I get a character. Okay, so this is A, this is B, this is C, this is D, and this is E, which is not there in the string, which is now it's F, and all these strings are 0. So this is a mask which will tell me why am I keeping the mask. I want to count the number of distinct characters, and let's say I am processing the next character, and that character is, let's say, string of I. Okay, and that character, let's say, is something like J. Okay, and I want to add this, so I will simply add into my mask by doing something like mask and or with I will or with the left shift of j minus a. I hope I will make you understand this again, but I hope you do get it. Okay, if you are trying to solve this kind of problem, trying to attempt this kind of problem, I hope you can set a bit in a mask at least. So let's say you want to set the mask in the jth bit, in the jth place you want to set the mask. So this is how you need to do. J minus a gives me the index, and I will left shift 1 and do an OR operation with this mask. Okay, so yeah, so that's how I will just keep a track of this, how many distinct characters. Because why do I need it? Because I need to keep a track whether it exceeds k or not. Okay, and how I am going to count the distinct characters? I can do it in a simple O of log n, and that in C++ you see there is already a function which is built in pop count. Okay, it will give you the number of set bits. So number of set bits, so I will tell you about that function later. You can just simply search it, or if you are doing some other language, what you need to see is that number of set bits in the mask, number of set bits uh, in the mask is nothing but your how many distinct characters are there. I hope that is clear. That is at least clear. Okay, how many distinct characters is nothing but the set bits in the mask, and that cannot go above 26, and that is very obvious. Anyone can understand that. Okay, so yeah, I will try to have a recursive solution. Okay, and yeah, so what are my states? What are my states of my recursion? Okay, so one thing definitely should be the index. Okay, the current index which I am on, I will try to use that base case that if index is greater than the string dot size, then try to return 0 and stuffs like that. Okay, so I need this index. Yeah, what do I need? I need a mask. Okay, I will not call that mask. I will call that current set. Current set I will call that in order to make things very simple and clear. And you see, I can change one time. I can change a string, right? Only one time I can change a string. So I can add another flag. It will be a boolean one. Is it allowed to change? If I have changed one time, I will set this flag to false, and this will also be a state, because when this flag is set to false, you cannot change any more string. So let's say you are iterating in a string. So in a recursive manner, you are actually iterating through this string, let's say, and at this point you have changed the character. Then I will set this mask, then I will set this boolean value allowed, which is to false. Okay, then allowed will be false, and in the subsequent in the subsequent iterations, or let's say at this point, in this point, you cannot actually change. So it will ensure that you are allowed to change only one time. Okay, so that's why I need a mask. I need an allowed bool function. Okay, so yeah, it will be a bool, and I can keep it integer 0 or 1 also, my wish. Okay, so yeah, I hope that is very clear and simple to understand. What I can do is simply write a function which will be index. Okay, and it will be curset, and it will be allowed. Okay, and you see, I need to pass the initial values, right? So s and k are also I am passing, and index I am starting with index 0. My current set is 0 0 0 0. This is nothing but my mask, right? Which is 0 0 0 0 right now, because I am not selected anything. And at first, yes, I am allowed to make a change, so I will make allowed is 1. Okay, so yeah, how many number of times do I need to make a change? It is nothing but 1. It is allowed. Okay, so even if the question asks you to you can change k characters, so this will also help me. So whatever be the case, yeah, I can simply have a function which takes first argument as definitely a string, second argument is nothing but the k over which you cannot exceed, third argument is this index, fourth argument is the mask, current set. Okay, current set mask, and fifth argument is nothing but allowed. Okay, whether you are allowed to change or not. And I will try to simply write this function. The base case, I guess, is very simple for you. If the index ever exceeds on this s dot size, what will you return, 0 or 1? If you think, you have to return 1, because you see the last set. So let's say you have reached the end of the string, right? So what does it mean? You there was a string something like this, and you have already processed the last character and allowed to go to the next place. Okay, now this definitely doesn't mean that you have already selected the last character. So the last index you can get, so you can get a set of 1, so you have to return 1 in this case. Okay, so you can get one more partition for the last one. Okay, so if you have ended up, because you see empty string isn't possible in any way also. Okay, so whatever be the case, I hope the base case is not difficult at all, it is simple actually. So now what I will do, I can write something. Okay, so let's say I will have a code. What is this code? It will give me nothing but s of index minus a. It is nothing but, let's say this code is very simple, right? For a it will give a 0, for b it will give a 1, and so on. This is nothing but the code which I just taken. Okay, and why I am using the code? Because yeah, I hope you do understand, because my 0th bit will be a, I can do a simple one left shift of code. If I do this one left shift of code, then 1 will be shifted that many number of times to the left, and I will get a mask in that way. I will get a mask in that way. Okay, and you see, I will try to have an updated mask, because I will try to take this element, my current element, into the set. So I will take an updated set instead of mask. So, and I will call that, what will I call it? I will call current set, or with I will do one left shift of code. Okay, I hope it is actually understandable for you. You are setting the coded bit. Okay, you are setting the coded number of bit in this updated set, because you are trying to see whether I can take the current element or not. Okay, so you see, you do this updated set. Okay, and uh, you can have a count which is nothing but built in pop count. Okay, this gives the number of set bits. So what it does, it gives the number of set bits. So that gives me, what does it give me? It gives me how many distinct characters are present. Okay, so built in pop count of what? Built in pop count of, let's say, the updated set only. So number of set bits on including current character. Okay, current character. Now after including the correct character, if you observe something like, hey, I have included the correct character, but my count is going less than, greater than k, so do not include this, do not include this, you want to say, right? And increase the partition also by 1. That's what, right? That's what. So what you will do, you can have a result, with you, let's say integer result, and you can set this result to 1 plus, because the partition got increased by 1 right now, it's less, greater than k, and you need to reset the things, right? The partition got increased by 1, so you call the function again, you pass s and k as it is, you go to the next index. Right now definitely the current index is processed, you want to go to the next index, and you want to start from the current bit, current character. Okay, so the current character is nothing but represented by this code. Okay, so your mask is very new now, you have reset your masks. Okay, earlier a mask contains some number of characters, some distinct characters, but now it has exceeded k. I want to reset my mask, and I want to start from the current element. Current element is nothing but code. I cannot take the current element, so I have to start from that. And you see, my allowed will be as it is. My allowed, yeah, no problem with that, right? And else what I can do is very simple. Else I can call this result is nothing but function sk, and index will definitely go +1, and one left shift code. No, this time not a one left shift code, because you do not need to reset right now. What will you do? See, on updating the set also, you still have not crossed k, so your partition may be still not over. Okay, so what do you need to do? You need to pass the updated set as the mask, and you are still allowed whatever, allowed or not allowed, whatever this boolean value says to you. Okay, now you have done this thing, but hey, if you are allowed to change a string, let's try to do it, right? If you are allowed to change a string, why I will not do it? because it will help me, right? It will help me so in increasing the partition. So I will choose to actually change the string. So this is actually a brute force solution, brute recursive solution, which I am showing you at first. So what can I do? What can I do in such a case? Okay, I can choose to update. Let's say 0 denotes A, 1 denotes B, and the same things, right? So you can have something like a new set. What will be the new set? It will be simple, right? It will be the same thing, 1 left shift of I. So I have chosen to take this set. So actually you see what I am allowed to do in the string is to replace one character by the other, right? So you see here in this updated set I am taking the current character. So instead of the current character I am taking the ith character. It means that I am replacing. So this actually simulates the replacing operation. Okay, so I am replacing current, I am replacing index, not index, okay, code, which is the current character index, by I. Okay, by I. So I want to replace and see what is the new set. Okay, I can have an integer for this, and for a new set, and I will also try to have an updated set. Not updated set the value I have already used here. I will have to try to have a new count again now, right? New count will be nothing but the same thing, built in pop count of this new set. Okay, I am having these two things right now, and you see the same things will flow, right? Same things I can tell again that what if my count, new count, is going greater than k, then what you need to do this time. See, result was initialized here, result got a value, its first value here. Now you need to maximize the thing, right? Whichever will give me you the maximum value. So 1 plus function of you can call it in the same way, sk index plus 1. Instead of 1 left shift code, instead of code you are having an I now, so you can have 1 left shift I. But hey, the allowed will be now false because I have used to replace. If allowed, I am using to replace the character, right? So allowed will be now false. Yeah, that is very simple to understand also. Should not be any difficult for you. Okay, so I don't think this should be any difficult. Okay, now result should be nothing but again maximum of result comma. I am deciding to see if it is increasing k, I have increasing the number of partitions. If it is not, I can take more elements, right? But hey, even if I do take more elements, I am, since I have done one change, I am not allowed to do any change. Okay, so it will give me new set here and sk and also the next index. Okay, so I hope it is very simple and clear for you, and you can simply return answer. Okay, you can simply return answer. So you try to see what will happen if I do run this code. Okay, we got a recursive solution, right? But will it give me a TLE? So some debugging, let's do it quickly. We have this result return, so let's try to run it now and check. So you see, we do get an accepted thing. If you try to submit this, will it work? Do you think it will work? Of course not, right? Because it is a recursive solution, and as I have told you again and again, this is a very brute force and it has an exponential time complexity. You need to memorize this to convert it into a recursive DP. So what are the three states of the DP? It is written here, right? Index, current set and count. Current set and whether it is allowed. So I hope you can write the DP right now, but hey, there is a trick. I am purposefully doing one mistake to show you. Okay, so you see what are the three states of the DP? You will think that it is index, current set and allowed. So let's try to do it and see what is index. Index number can go till 1E4, right? So let me keep this, and current set is nothing but uh, what is the current set? It's 26. So let's keep 26, and allowed can take two values, so let's keep 2. Okay, and what I will do, I will try to memset this DP to all -1. Okay, so I will try to memset this DP and set all its value to -1. Okay, I hope you know all these things. If you do not know basic recursion and memoization, then I will tell you you are trying the wrong problem. Okay, this is definitely not for those who do not know basic recursion as well as memoization as well as and catching. And if you are struggling to do those recursive things, recursive DP at least, you can follow my DP playlist. You can go to my channel and definitely follow it. I will very soon add the next video for that also. Yeah, so if what I will do is that this, since this is the catch type of thing, if I take something like if dp of this index current set and allowed, if it is not -1, -1 denotes that it is an empty cell, right? If it is not -1, then you do not need to calculate it again. You can simply return this current set and allowed. Okay, and what will happen right now is that while before returning, you can return, before doing this you can just do what, return index current set and allowed. So return, let's say index, and let's say current set, and let's say allowed. You can just save the state, right? Before returning, you just do one thing, you just save the state and then return. And if you see that it has already been calculated, do not calculate it further. Okay, so the instinct which is there in your mind is that, hey, if we try to submit this, this should work, right? But let's try to see. Okay, well, let's try to see and understand what fault it gives you. Okay, so error expected closing bracket. Why are they expecting a closing bracket over here? Current set allowed. So in this line number 7, dp of, yeah, so this thing is there, right? So what if I try to submit this? Do you think it will work? It is telling out of bounds. Hey, what is out of bounds? Why you are telling out of bounds? Let's try to run it at least. Oh my god, it is still telling me out of bounds. So why exactly? You see, this is a bit mask, right? This current set is a bit mask and not 26. Though it will have very less values, but it is actually 2 to the power 26. And if you try to set that as a DP in this way, it will be wrong. Okay, so what can you do? Tell me if you already knew this. You can do a map for this. We can try to do let's say unordered map. So did you know that unordered map can also be stored in this way? And you see, you have a value, key and a value. So I will use this current set as the key. Okay, so there will be no limit because vector has some limits in storing the indices, but for map there will be no limit. And I can, instead of this -1, I can just do count of this current set. Okay, if there is a count, I will return this, and here I just need to swap these things out, right? So it will be nothing but allowed and current set, which will be set to result. And you can choose to delete this mem set because it's no longer -1. I am trying to see that whether this current set is present or not in the map. If it is present, you try to return the value of this DP, which is nothing but that. Okay, and in this key, so this is basically the map. Okay, you try to see it like this is the map, this is the key, this is the value. Okay, so here this, in this way also you can write a DP. And if you try to submit this now, this will not give an index error to you. Okay, okay, so it is actually still giving you out of bounds for type unordered map. So let's try to see why exactly it is still giving you an error. Okay, so you see this thing will be swapped, right? Current set is at last now. So yeah, because this is the key, again I am telling you, this is the map, this is the key, and the whole thing which is returning is the value of the key, corresponding key in the map, right? So now if you try to submit, and check, you see you do get an accepted thing. Okay, and I hope the solution I was able to make it very clear for you. I will try to, you can try to optimize this. Okay, instead of using a 3D DP, you can do a 1D DP also, right? Now you might be thinking, wow, will I do a 1D DP? You can use a long integer and store this whole thing in the mask, right? And some more operations you can also do. I will try to do this. If it's the same code, right, I can do continue here. And what if I choose to remove this map, try to submit it? You see, you can actually make it more optimal. You do get a 35%, which is okayish. Okay, and you see, what I was telling you is that you can convert this into a 1D DP also. So how? These three states of the DP, you can choose to denote it in this way. So you have a large integer. Okay, you have a large integer. The first bit you can use for the allowed. Okay, whether it is allowed or not, the first bit represents 0 or 1, you can use for the allowed. The next 26 bits you can use for the current set. So next 26 bits you can use for the current state, and the remaining bits, okay, so the remaining bits you can use for the index, and it will be a long number. Okay, it will be a long number, and you can store this as a long and try to solve it. It will actually improve your time complexity also, because from a 3D DP you are just going a 1D DP, and literally there is one index. So every DP you can actually convert it in this way. Okay, if it is representable in the form of mask, you can use a big bit mask. Okay, but I did not show you this because yeah, it will make things more complicated, and I will do a lot of bitwise operations in between. You will get confused, right? But I hope this method is actually very clear and crystal clear to you, and I hope the solution looks at least easier than what is there in the editorial. You see, what they are doing actually is confusing you. Okay, nothing else. We are trying to write the iterative DP directly for this, and trying to do a whole lot of different things. Okay, I don't know why they are trying to make it more complicated. People are just telling that it is a crazy problem, and it is very difficult, the editorial, by looking at the editorial. But I will tell that the problem is not actually that crazy, it is rather the editorial's mistake. And even if you try to see some of the solutions here, you will get confused. Prefix sums, suffix sums, they are using a lot of different things, which is also not very clear. uh, Clearly they have not explained. So yeah, I hope the explanation, my explanation was at least clear to you, and you did understand something at least. Okay, and yeah, if you have any doubt, you can definitely ask me in the comment section. Yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.